Next one, eighth one, I equal to integral over x into tan inverse of x dx. As I told, you need to follow I lateral. Here what is I? Inverse. Inverse is nothing but tan inverse of x. That will be u. And dv will be x into dx. When you integrate, you will be getting, if you are thorough with the formulas, it's very easy. Du equal to 1 by 1 plus x squared. When you integrate this, you will be getting x squared by 2. So it is uv, that is x squared by 2 into tan inverse of x plus v du. V is x squared by 2 into 1 by 1 plus x squared into dx. So I have written it here. Now you can take 2 outside. As I told, if you have the numerator and denominator, if you have x squared, you should add and subtract 1. So I have added and subtract 1. Since x squared is positive, I am not taking minus inside. Now after that, x squared plus 1, separate together. This is one term, this is one more term. Separate the integral. Yeah, x squared by 2 into tan inverse of x as it is, minus 1 by 2. Here when you integrate, x squared plus 1 divided by 1 plus x squared into dx. So you are separating the integral. This minus sign is common for both, and minus, so I have given a bracket. This bracket is also very important. Integral over 1 by 1 plus x squared into dx. What is this? This tan inverse of x. Now this 2 will get cancelled, so you will get integral over dx. Integral over dx is nothing but x. So x squared by 2 into tan inverse of x minus half into x, minus into minus will become plus. It is half into tan inverse of x plus c. That is the value of the integral. Always highlight the answer with pencil. The next one, I equal to integral over x cos inverse of x into dx. Now inverse trigonometry, inverse function is cos inverse of x. The remaining function is x dx. U equal to cos inverse of x. dv is nothing but x dx. Therefore, when you differentiate this, you will be getting minus 1 by root of 1 minus x squared into dx. To get v, you need to integrate this. When you integrate, you will be getting x squared by 2 by applying integral over x power n into dx. Now the formula is for a parts integration by parts. It is uv minus integral v du. uv is cos inverse of x into x squared by 2. And v du minus integral over x squared by 2 into minus 1 by root of 1 minus x squared into vx. That's what I have written here. Now minus into minus will become plus. But here what we have? Minus x squared. So I am not multiplying this minus. I am keeping minus x squared as it is. I am taking 1 by 2 as common. Therefore x squared by 2 into cos inverse of x minus 1 by 2. This minus sign I am considering with x squared, therefore minus x squared divided by root of 1 minus x squared into dx. If you have x squared in the numerator and the denominator, you need to add and subtract 1. If you have x and 1 minus x squared, you need to take this as t. This also I told in one of the sum. So you are going to add and subtract 1. This is 1 plus 1 and this is minus 1. After the next step, what we are going to do? We are considering this is one term and this is one term, and we are going to separate the integral. So x squared by 2 into cos inverse of x minus 1 by 2 is common for both. So integral over 1 minus x squared by root of 1 minus x squared into dx minus integral over 1 by root of 1 minus x squared into dx. So when you get cancel, you will get 1 minus x squared. Now this is nothing but the question. What is the question? It's in cos inverse. So what you can do is you can take, answer should also be in terms of cos inverse. So this minus, when you take inside, this will become plus. That's what I have written in the next step. X squared by 2 into cos inverse of x minus 1 by 2 into integral. When you simplify this, you will get, and this minus I have taken inside, and you will get minus 1 by root of 1 minus x squared into dx. Now this is nothing but, this formula for this is cos inverse of x. And this is nothing but root of a squared minus x squared into dx, the formula which I told in page number 329. So we are going to apply that formula that we have done in the last sum. I equal to x squared by 2 into cos inverse of x. The formula for this is that is x by 2 into root of this question 1 minus x squared plus a squared by 2. A value is 1. Therefore 1 by 2 into sine inverse of x by a is the formula. A is nothing but 1. That's what I have written here. X by 2 into root of 1 minus x squared plus 1 by 2 into sine inverse of x. Plus this value is nothing but cos inverse of x. So I am going to multiply this minus half inside. So minus half is here. Now here this is nothing but plus cos inverse of x. When you multiply minus half to it, you will be getting minus half cos inverse of x plus c. After that, what we are going to do? We are going to multiply this half to the and we are going to simplify this. That's all. So for integration is over and we are going to simplify this. This is nothing but this first term you are writing as it is, and this is minus x by 4 root of 1 minus x square. When you multiply this, you will get minus 1 by 4 sine inverse of x, and this is nothing but minus 1 by 2 cos inverse of x plus c. That's what I have written. And as I told, everything, since the question is in terms of cos inverse, our answer should be in terms of cos inverse. So the sine inverse, as you have learnt in inverse trigonometry, sine inverse of x can be written as pi by 2 minus cos inverse of x. In the place of sine inverse, I am going to substitute as pi by 2 minus cos inverse. The small change I have done is, in the place of sine inverse, I have substituted pi by 2 minus cos inverse, and the remaining terms I have written as it is. Now, the remaining terms, to check whether I have written as it is, the next one. So, x squared by 2 into cos inverse of x minus x by 4 root of 1 minus x square minus 1 by 4 into pi by 2 is a constant. So, no need to write, since constant, when you add constant to a constant, you will be getting a constant. So, I didn't write. At last, in the final step, I didn't write pi by 8 plus constant is also constant. So, in the last step, I did not write that pi by 8. So pi by 8, here it is plus cos inverse, so 1 by 4 into cos inverse, and this minus 1 by 2 into cos inverse plus c. Now when you add these two, you will be getting minus 1 by 4 cos inverse of x. For this term I have written, this term I have written, these two I have added and I have written minus 1 by 4 cos inverse of x. These two are constant. So I have written constant. The next question, I equal to integral over sine inverse of x the whole squared into dx. Here you will be wondering, there are no two terms. There is no product of two terms. So here also don't worry about that. The sine inverse of x the whole squared is one term and dx is one more term. Here we cannot apply any of the methods which you have learned so far. So inverse function is first. So you should take the whole term. U equal to sine inverse of x the whole square, and dv is nothing but dx term. So when you differentiate that, you will get first power, PTA rule, 2 into sine inverse of x. When you differentiate this sine inverse of x, you will be getting 1 by root of 1 minus x squared into dx. Now when you integrate this, you will be getting x. So uv, x into sine inverse of x the whole square minus v du. V is x, du is 2 into sine inverse of x by root of 1 minus x squared into dx. So I have written 2 sine inverse of x into x divided by root of 1 minus x squared into dx. Now here you can, this 2 you can take it outside, and the remaining terms you can write the first algebraic term, then the remaining terms, and you can take this to be integral I1. Now we need to split this, you need to integrate this integral. So for this here also it is in terms of product. So you will be applying highlight rule. I is sine inverse. The remaining term is nothing but dv. So yeah, u equal to sine inverse of x. dv is nothing but x into dx divided by root of 1 minus x squared. When you differentiate this, you will be getting 1 by root of 1 minus x squared into dx. As I told already, if you have x in the numerator and x squared in the denominator, you need to take this 1 minus x squared to be t. When you take t to be 1 minus x squared, dt will be minus 2x into dx. X dx alone you have, so bring this minus 2 to the denominator. Just you are going to substitute in the integral. X into dx can be written as dt by 1 by minus 2. So I am taking minus 1 by 2 dt divided by root 1 minus x squared. Therefore it is root t. Root t can be written as t power minus half into dt. Now when you apply integral over x power n into dx formula, you will be getting t power half divided by half. When you reciprocate that half, the denominator t power half divided by half is there. Now I told you to reciprocate and write. So I will get this minus half into 2 by 1 into t power half. T is nothing but 1 by x squared. That is, this is t power half is nothing but root t. Therefore it can be written as, the 2 and 2 will get cancelled. You will get minus root t. This t value is nothing but 1 minus x squared. Therefore v value is nothing but minus root of 1 minus x squared. Pause this video and do it on your own, then only you will understand. After that we are going to substitute uv. U into v is what? Sine inverse of x into minus root of 1 minus x squared. Then minus integral over v du. V into du value is this one. Therefore minus integral over minus root of 1 minus x squared into 1 by root of 1 minus x squared into dx. That's what I have written. This is v value and this is du value. Now these two will get cancelled. Minus into minus will become plus. Now this minus I am taking outside. Therefore it is sine inverse of x into root of 1 minus x squared plus integral over dx. Integral over dx is nothing but x plus c. So this I1 we are going to substitute in this integral. I equal to x into sine inverse of x the whole square plus in minus 2 into I1. Therefore minus 2 into I1. Minus 2 into I1 value is minus root of 1 minus x squared into sine inverse of x plus x plus c. Therefore minus 2 into this term you will get plus 2 into root of 1 minus x squared into sine inverse of x. Now when you multiply this minus 2 into x, you will get minus 2x plus add constant of integration to it. The next one is also the same thing what we have done in sine inverse of x. Here is half of the step here. I equal to integral over x cos inverse of x into dx by root of 1 minus x square. Always inverse function will be u. Therefore u equal to cos inverse of x. dv is the remaining term which is present in the integral. Therefore it is x by root of 1 minus x squared into dx. When you differentiate this, you will be getting minus 1 by root of 1 minus x squared into dx. When you integrate, as I told, if you have x in the numerator and x squared in the denominator, you will be taking this term to be t. When you take t to be 1 minus x squared, dt will be minus 2x into dx. Since you have x into dx, bring this minus 2 to the denominator. After that, substitute the integral. X into dx can be written as dt by minus 2 divided by root of 1 minus t squared into x squared you have taken t. Therefore, root t. Now, minus half you can take it outside since it is a constant. Root t can be written as t power minus half. Now, when you integrate by applying x power n formula, you will be getting t per half by half. This 1 by 2 you need to reciprocate and write. When you reciprocate, that is half and half will get cancelled. You will be getting t power half minus t per half. That is nothing but minus root of t. Minus root of t value is nothing but 1 minus x square. So after that apply in the integral uv minus integral v du. That's what I have substituted here. uv minus integral v du. Therefore, these two terms will get cancelled. Minus into minus will become plus here. Minus, minus. The integral itself will become plus. Therefore, here it is minus integral over dx. Write this term, bring this minus outside and write it here. Integral over minus integral over dx is nothing but x. And add the constant of integration to it. Thank you, students.